Okay, in this video we're going to look at graphing radical functions, and we did do an example of graphing radical functions in a previous video, but I did not have the graphing utility with me, so I want to go ahead and work on this with the graphing utility. So in a previous video we talked about these two particular questions. We were looking at the domain and range for our radical functions. We have the domain, which is x is greater than 2, and the range, which is y is greater than or equal to 5. Then we have down here the domain being all real numbers and the range all real numbers. So let's test these two using our graphing calculator. So what I'm going to do is I'm going to take the graphing calculator and I'm going to graph these two particular functions, number 1 and number 3. And I've chosen these two because number 1 is a square root and number 3 is a cube root. So in order for us to graph this, for number 1, I'm going to go to y equals, I'm going to hit second x squared, which gives me my square root, and then I'm going to put parentheses x minus 2. I have to encase the x minus 2 in parentheses because that is my entire radicand. Remember, the radicand is the value or the expression that is under the radical sign. We have to put it in parentheses so the calculator knows that we are taking the square root of the entire expression. Now, once we've done this, if you look at the original, the 5 is not underneath the radical sign. So we have to take the arrow here, as we're prompted, and move the arrow outside the radical. As you can see, it's no longer under the radical sign. Then I'm going to add plus 5, and I'm going to go ahead and graph. And as you can see, we talked about HK form. I'm going to move this here. HK form is of a radical function. You have a times x minus h plus k. And in a radical function, the hk value, the point hk tells you two different things. In a square root, it tells you the vertex or starting point. We can call it a vertex. It's technically the starting point of the function. And in a cube root, it tells you the inflection point, just like we do in a cube. And this is because a cube root is actually an inverse of a cubic function. And we're going to talk about that a little bit more when we do our next lesson on inverses. So anyway, let's check this out. So according to what I have here, the domain, all x values should be greater than or equal to 2, and all y values greater than or equal to 5. Now this also indicates that my vertex should be at 2, 5. That's my HK, based on the 2 and the 5. If you look at the graph on the calculator, this is at 2, 5. This is where it starts. If you go to the table, and you look at the table, and you look at any values less than 2 for x, you get an error output for y. So that is why all x values have to be greater than or equal to 2. We cannot have a negative value underneath the radical sign. And if I do anything less than 2, I am going to get a negative value under the radical. I cannot take the square root of a negative number. I can take the cube root of a negative number, but not the square root. We're not dealing with imaginary numbers or I. We're looking for actual real values we can plot on the graph. So you see I've got an error there. Same thing, you can see that my smallest y value that works is 5. So that is where we get our domain and range. So now let's take a look at number 3 and let's look at our cubic function. So I'm going to go and I'm going to take the graph, I'm going to clear the first graph, and now we're going to look at number 3. Now that's a cube root. Remember to be very careful when you enter these in here. I always would circle the index so I knew what root it was I was taking, which is the cube root. So there's two ways you can enter this in the calculator. We're just going to focus on using the radical sign because we haven't gotten to fractional exponents yet. So I'm going to go math, and I'm going to choose number 4. As you can see, number 4 is the cube root. That gives me the same setup as I had with the square root, but now I've got a cube root. My radicand, again, is the entire expression, x plus 1, so I'm going to put parentheses, x plus 1. And then I'm going to arrow out, because my k value, negative 4, is not underneath, minus 4. So let's go ahead and look at that graph. And as you can see, this graph is continuous and it keeps going. So when I look at the domain as all real numbers and the range is all real numbers, that means that I can plug in anything for x. Any x value can be an input, and it means that any y value can be an output. If we were to expand this infinitely, you would see that as slow as it's moving, it would keep getting bigger and bigger going to the right on the positive end, and it'll keep getting smaller and smaller going to the left. So all the x coordinates are included as well as all the y coordinates, which is why we have all real numbers. Now in this particular example, our HK is -1, -4. And if you remember, the H is always opposite of what's underneath. So if it's a +1, it's minus, because the formula says x minus h. So it's whatever we are subtracting. So we're subtracting a -1. That's the only way we can get +1. So if you look on your graph, that -1, 4 is not a vertex per se, it's an inflection point. That's where our graph changes its behavior. And when we get really in depth, we'll talk about concavity, or being the concavity of the graph and how it changes shape. But that's the point of inflection. If I were to hit the trace button, you can see that my cursor, while not being able to be perfect on this, because it jumps on me here, but you can see that the inflection point is going to be close to -4 for y and -1 for x, which is our inflection point. So that's how we graph those functions. Now let's look at some of the examples that we have down here. As I'm looking down here on these examples, let me try to graph this first of all by hand. I've already graphed it, well, we graphed it by hand on the previous lesson, so we can look on the previous lesson. But I know that my vertex, since this is a square root, my starting point is going to be at 0, 5. And that's because the x is by itself. That's the same thing as having x minus 0. So that is where I got the 0. So I'm going to go to 0, 5, and I'm going to plot my point. So that's going to be my starting point. Let's pick a couple of points around it. I know that I can't plug in anything less than 0 because I can't take the square root of a negative number. So let's try 1. If I plug in 1, I have the square root of 1, which is 1, plus 5, which is 6. So that's my next point at 1, 6. Let's try 2. Let's take another point. I'm going to plug in, well actually, let's go to one that would be easy. Let's go to a perfect square, which is 4. Because if I plug in 4 here, I can take the square root of 4 easily, which is 2. And 2 plus 5 is 7. So our next point is going to be at 4, 7. So at this point, you can see the behavior of the graph, and you can see where it goes. And it's just going to gradually, that's not the best drawing, gradually increase. Okay? So that is where we end up with our graph. If we do this on the calculator, you should get the same exact thing. I'm going to go to y equals, let's go ahead and clear this out. Again, you hit second, x squared, which gives you the square root, x, arrow out so that your radicand is the only thing underneath the radical, plus 5, and graph it. And you'll see we have identical to what we just plotted. If you look at the table, you'll see that we have the same values. When x is 0, it's 5. When it's 1, it's 6. We skip to 4 because it's a perfect square. It's 7, and so on. So you can see what your domain and range are. But again, look what happens if we go below 0 for x. We get an error for y. We cannot input anything less than 0 because that would give us the square root of a negative number. So let's do one more example, and let's do a cube root. So I'm going to come back here and I'm going to do number 10. So we'll do number 10. Apologize for that. All right. So let's look at number 10. Number 10 is a cube root function. So we're not going to have a vertex per se. We're going to have a point of inflection. So I'm going to first identify my point of inflection, which is the point on the graph where the cubic changes shape. If you remember, our HK form for a cubic looks like this. And HK is our inflection point, or point of inflection. However you want to say it, point of inflection and inflection point, that's up to you, that's your preference. So I'm going to first find that inflection point, so I at least know where the center, well not really center because we're infinite here, but where the behavior of my function changes. So let's identify that inflection point. In this one, it's x plus 1, so that would be a negative 1 for your h value, and your k value is 4. So that means that my point of inflection on the graph is at negative 1, 4. That's your point of inflection. We call that POI. You'll see that written as POI sometimes. And so let's start plugging in points around it. And I'm going to go back here to y equals, and we'll use this in just a second. Let's plug in some points around it and see what we get. Well, we want to try to pick something square root-wise that we can plot, or cube root-wise that we can plot. And we don't have restrictions on cube roots because you can have a positive or a negative cube root. So the smallest cube root that we know is going to be, we can actually take the cube root of 0, because it is 0. So if I plugged in negative 1 for x, I get 0 underneath, plus 4, and 1/2 of 0 is 0, plus 4. But what do you notice about that? That's our inflection point. Our inflection point is when we get a 0 value underneath the radical sign. That's why we do x minus h, and that's why we choose the h that we're subtracting, or the value that we're subtracting from the x. So that I just wanted to show you that that's where the inflection point comes from. It's when we get a value of 0 under our radical. So let's go to the next thing. Well, we can find the cube root of 1, so let's make x 0. If I plug in a 0 here, that's 0 plus 1, which is 1. The cube root of 1 is 1. 1/2 of 1 is 1/2. Add 4, and we have 4.5. You can plug this into your calculator. All I'm doing is taking this value and substituting it in for x. So our next point is going to be at 0, 4.5. Well, let's get negative 1 now. We can take the cube root of 1. We can also take the cube root of negative 1. I'm going to use the same color. So you can see these are mirrors of each other. So I'm going to plug in negative 2. Because if I plug in negative 2, I'll work it out right here so you can see it. If I plug in negative 2, what that's going to create for me is I'll have 1/2 the cube root. Remember, it's a cube root. Negative 1 plus 4. What is the cube root of negative 1? Well, it's negative 1. So I have 1/2 negative 1 plus 4. So it's going to be negative 1/2 plus 4. So that's going to leave us at 3.5, or 3.5. So when it's negative 2, the point is 3.5. Do you see how those two orange points are mirrors of each other? So now let's choose a different color. We'll go purple. We'll go green. Go green. Now let's try to get the next cube root. I can take the cube root of 1. The next perfect cube is 8. So how would I get an 8 under here? I would choose 7. Once I choose 7, I can plug the 7 in, and I'll do it over here. I have 1/2 the cube root of 7 plus 1 plus 4. Well, the cube root of 7 plus 1 is the cube root of 8, which is 2. So I have 1/2 times 2 plus 4. Well, 1/2 of 2 is 1, so that's 1 plus 4. So when x is 7, y is 5. So I'm going to go out here to 7, 1, 2, 3, 4, put a point at 5. And let's pick one more. Let's try to get a negative 8 under here. So to get a negative 8, I need it to be negative 9. And I'll work it out over here. The reason for that is 1/2 the cube root of negative 9 plus 1 plus 4 will give us a negative 8 underneath. And the cube root of negative 8 is negative 2. So I have 1/2 of -2 plus 4. 1/2 of -2 is -1, so I have -1 plus 4. So that gives me 3. So I come out, and I'm going to extend it a little bit to -9, and the point goes to 1, 2, 3. So what I can do now is I've graphed this cube root function. You can see the behavior. There's your inflection point, the first one I did, and you can see how it extends. If we were to graph this on the calculator, you have to make sure that you enter this properly, especially for your A value. The A value is 1/2. You need to enter that in as a fraction. If you want to enter it as 0.5, that's fine, but not all fractions are going to be so nice and neat. So we're going to take 1/2 of the cube root, so you hit math, and 4, the cube root, and my radicand is x plus 1. I'm going to move out, plus 4, and I'm going to graph. And you can see that the graph is going to look very similar to what we have. If we were to actually go to the table, you would see on the table the same values we just plotted. So I plotted -9, and what was my y value? 3. It's the same one we had here. Okay? And you can see why I chose the ones I did. If I chose -2, we got 3.5. If I chose -1, we got 4. That's our inflection point. If I chose 0, we got 4.5, and those are all the points that I picked. So that is how we graph cube roots and square root functions. We will see in our next lesson how these are actually inverses, and that's going to be our next lesson, is inverse functions.